Okay, we are going to go over the formative, the photosynthesis and cellular respiration formative. Our first question says, identify the products in this equation and how does this equation compare to cellular respiration? Okay, so we have carbon dioxide and water coming in with energy from the sun. Chlorophyll and the chloroplast is capturing that energy. We're producing glucose, C6H12O6, which is glucose, one molecule of glucose, and H2O. If it were balanced, remember we would go back and we'd put a 6 in front of the CO2, 6 in front of the H2O, 6 in front of the oxygen. And then there's already 6's here, so we don't have to put a 6 on that one. Okay. And the arrow always points to the product. So point to the product. So identify the products. The products would be the sugar, the glucose, and our oxygen. That's going to be our products, but it also says, how does this compare to cellular respiration? Well, this is photosynthesis because we have sunlight coming in. The energy is being captured by the chlorophyll. That energy has been stored in this sugar molecule for later use in cellular respiration. So these products from cellular respiration are going to go, and from these products from photosynthesis are going to go into cellular respiration and be the reactants for cellular respiration. Photosynthesis is building the glucose. Cellular respiration will be breaking it down and making carbon dioxide and water and ATP energy. So it is the opposite of cellular respiration. Our products again are the sugar and the oxygen, the glucose and the oxygen, and it's going to be the opposite of cellular respiration. So we can eliminate those two because those are the reactants. So C6H12O2 is opposite of cellular respiration. This would be our correct answer right here. Our products of photosynthesis are glucose and oxygen, and it is the opposite process of cellular respiration. What are the differences between light-dependent and light-independent reactions in photosynthesis, and what is the product of each? Okay, so this one says light-independent needs light. Well, it says light independent. If it's independent of it, it does not need it, so we can eliminate that answer. This one says the light independent reactions do not need light to produce glucose. Okay. So the light independent reactions, they do not need light, and glucose is being produced in there, in the light independent part. And light dependent reaction does need light. Light dependent needs light. Light independent does not need light. The glucose is being made through the light independent part. We're making some ATP, some NADPHs in the light dependent part, and the light energy is needed for that part. What is the role of ATP in the cell? So ATP provides the stored up energy. It's like a battery. When it's charged up, when it's ATP, it's a charged battery, remember? It has all that extra energy in that bond holding that third phosphate. And then when that third phosphate breaks off, it releases that energy the cell needs for processes. Carry out those life processes. And then it's a rundown battery, ADP, adenosine diphosphate, only has 2 phosphate groups. So to be recharged, you have to add a phosphate group back to ADP to make it ATP again. Adenosine diphosphate back to adenosine triphosphate. And it provides energy. It has energy stored in that bond. It provides energy for the cell to carry out processes. So how many molecules of ATP are produced in the entire breakdown of glucose? It depends on the efficiency. It's going to be about 36 to 38. Oops, it's going to be that. It's going to be about 36 to 38 ATP produced from 1 molecule of glucose, depending on the efficiency of that cell. 2 from glycolysis, remember, 2 from the Krebs cycle, and about 34 or so from the electron transport chain. Happening in the mitochondria, cellular respiration making ATP in the mitochondria. Next says identify the type of fermentation. It's either alcoholic or lactic acid. It causes bread dough to rise. That's yeast. Yeast are doing alcoholic fermentation, making those carbon dioxide bubbles that make the bread lighter and fluffier. Identify the type of fermentation that contributes to the sour taste. So if it's saying sour taste, buttermilk, sour cream, pickles, sauerkraut, that sour taste comes from lactic acid fermentation. So lactic acid fermentation, lactobacillus bacteria in yogurt are producing lactic acid that gives it the sour taste. Sour taste for buttermilk, sour cream, pickles. Sour taste is going to be lactic acid fermentation. Identify the type of fermentation that causes muscles to be sore the next day after an intense workout. And again, that's the buildup of lactic acid in those muscles due to not getting enough oxygen in there. Those muscles are working hard using lots of ATP and not getting enough oxygen in there, then it's going to switch over to anaerobic without oxygen, anaerobic fermentation. So lactic acid fermentation is an anaerobic process. If there's enough oxygen getting there, it goes all the way through the cellular respiration process, efficiently breaking down glucose, make lots of ATP. If there's not enough oxygen present, then that is a very inefficient process, does not completely break down the glucose. In our muscles, that would be lactic acid fermentation. And that buildup of lactic acid is what makes muscles sore.